All right, here's Geometry Notes 9.2. Calendar's a little bit mixed up. We're going to finish 9.2 on Friday, and if I can swing it right, well, next week will be totally different, so not really important. But we're going to be talking about arcs and chords today, the properties of arcs and chords of circles. The first concept we're going to talk about is what's called a central angle. All right, an angle whose vertex is at the center of a circle is called a central angle. So the measure of angle PQR in this instance is 90 degrees. Now I want to take time to point out that the measure of the arc length right here, arc PR, is also 90 degrees. We haven't talked about what they are or how they work, but if the central angle is 90 degrees, so is the arc that matches that same space. Okay. All right, so if we label this circle, this is just prep work for example 7.9. Label the center as K and then draw a horizontal line to L. Now, it says here to draw at 60 degrees, but when I look at try and draw 60 degrees, I look at 90 and try and think if I cut that in thirds, I'd get 60 degrees. That's how I draw something that's about 60 degrees. Then I continue it through to N, and this is the shape that I should have on my example 9.7 notes to help me out. We're going to use this information about central angles and other things to do math today, but a definition you might want to know, if I say the word minor arc, you may want to know I'm talking about an arc that's less than 180 degrees. So this angle, this arc right here, PR, that's a minor arc, and it measures 90 degrees because it's the same as the central angle. All right, notice in your notes, it's written wrong. An arc should be written this way with a nice curved shape on top. The way it looks in your notes is more like a top hat or something, like a little pointy hat. Not okay. That's not how it should look. So change it, or remember on the test, I'm going to expect you to write your arcs written this way. Okay, really important. Do not forget. Curved shape for the arc. So now, new symbol. Okay, because there's a big difference. If I, let me get my marker. Okay, if I write PR with a segment above it, that means I'm connecting P and R with a straight line. But now we have something new. If I can connect P and R with a curved line, then I have to have a curved symbol telling me I'm talking about the arc PR and not the segment PR. Okay. This information is found on your cheat sheet. We're going to be using this whole section of circles. Okay. Now there aren't any formulas really. It's just the pictures. The pictures are the formulas. Okay. Right here, if I look at I've noticed the central angle. I mentioned the word central angle. So notice how the central angle is equal to the arc length. There's your formula. There's no y equals mx plus b or anything fancy like that from algebra. We're using a picture to help us with the questions. So please, please practice this. Okay, if you hear me say the word major arc, a major arc is bigger than 180 degrees. And here we have arc PSR. Arc PSR starts at P, has to go through S, and then around to R. Okay, arc PR just goes directly to P and R. It's the shortest distance. But if I want to go around this other direction, I have to go PSR. Again, the central angle for arc PSR is angle PSR, or 270 degrees. Okay, so here we have central angle, major arc, and minor arc. Now, if I have a special kind where it's not bigger than or less than, it's just exactly half of a circle, we call it a semicircle. And I'm pretty sure you're familiar with that. And semicircles measure 180 degrees because it's half of a circle. Here we have a minor arc is the small part. The major arc is bigger than 180 degrees. If it's exactly 180 degrees, it's a semicircle. So let's go ahead and name each of the arcs and angles created and note their measures. First one, it says MKL. Well, MKL is 60 degrees and ML is the arc. And that is also 60 degrees because it measures the same as the central angle. So LKN right here, that's going to be, well, what is it going to be? Here's 60. The other side, we have to form a straight line. They're a linear pair. So that means that 60 plus whatever has to equal 180. Well, 60 plus 120 makes 180. So LKN is measured at 120, and the arc M, that's a typo. That should say NL. I doubt I can. Not even gonna try. So scribble that out. It should say NL. This arc here measures 120 degrees. It's weird to think of arc length as an angle, but hopefully you'll be comfortable with it. We need to denote arc length as 120 because we use the actual, if you want to find a distance, then we use that information in different calculations to find out how exactly long it is with relationship to the radius. But arc length will always be measured in angles, degrees. So if we look at the measure of MLN, here's M, we go through L and get to N. How big is this whole half? Well, it's a semicircle, 180 degrees. MNL, we like this. We go this way, that's 180 degrees. Plus, we've got to go a little bit further, so it should be 180 plus 120. It should be 300 degrees total. Now, the arc of ML, MN. Here I am L, I go M and then N. So here's 60 plus 180 should give me to 240. That's kind of how we measure arc length, and that works with central angles. So whatever the central angle is, that's the same as the arc length. So we can add two different arcs together, no problem, or we can break it apart into two different pieces. So arc ABC is equal to AB plus BC. Okay, if we find the measure of AD, BAD, that should be 80 degrees. And then it says BAC, well, that's the diameter, so that should be 180 degrees. Measure of angle CAD, that's, well, if this one's 80, the whole thing's 180, then this side over here has to be 100. So now if it asks us to find the arc E, here we go. Remember how we're supposed to change this? It's not hard, it's smooth, it's curved like that. But arc BD is going to be 80 degrees. Arc CD is going to be 100 degrees. Arc BEC is going to be 180 degrees, half a circle. And we also know that two arcs are considered congruent if they have the same measure. So what's cool about this is we can use isosceles triangle type stuff where we have two segments that are congruent. If those two segments are congruent, then so are the arcs that they subtend. That's a big fancy word for what they cover. So this segment, AB, if it's congruent to BC, then we also know that AB is congruent to BC. That's what it says right here. If the arcs are congruent, so are the segments. And since it says if and only if, we know it goes both directions. It's a biconditional statement. Okay. So let's use that information here. We say PS is equal to 12. PS is 12. PR is 15. But if we look at the measure of the arc over here, from S to P, that covers 70 degrees. Well, RQ over here also covers 70 degrees. So since these arcs, RQ is congruent to SP, that means that RQ's segments must also be the same. So SP is equal to, SP is 12, so that means RQ also has to be 12, since their arcs are the same amount. Okay. So if a diameter of a circle is perpendicular to a chord, just like this, I've got a diameter and I've got a chord DF, and if they are perpendicular, then the diameter bisects the chords and its arcs. Meaning that if I have the situation, a diameter bisecting a chord, then ED and EF is congruent, so is DG and GF. They are both congruent to each other. You're going to see that on your homework a lot. Familiar with this specific example to help you go back through and do your homework. We're going to use it right here. So I have SQ equals 12. SQ equals 12. AT equals 8. Okay. So I know that because it's perpendicular, it bisects it. That's where that comes in. So because it's a diameter and it bisects it, we know that it's got to be half of 12. So this one's 6. This one's 8. SA, ooh, I can do that one. That's Pythagorean theorem. 6 squared plus 8 squared equals this. If you notice your Pythagorean triples, this is a 3, 4, 5 doubled. It's going to be 6, 8, 10. Triple. So since SA is 10, isn't SA a radius? Okay. So isn't AP also a radius? So this one up here is also a 10. And AR, this one's also a radius of 10. So that means that PR is just a length of 20. Booyah! I like that. Okay, so we've got all that information down. If one chord is perpendicular, okay, if one chord is the perpendicular bisector of another chord, then the first chord is a diameter. Okay, so we have two chords that are perpendicular and bisects right here. If that's the case, then the chord HG is a diameter. So this is kind of like the biconditional of the other statement we had, where it said if a diameter bisects is perpendicular bisector of a chord, then it bisects it. Yeah, that's right. If a diameter is perpendicular to a chord, then it bisects it. But now we're working backwards. If it bisects it and it's perpendicular, then it's a diameter. Okay, a new rule to talk about. If the same circle, in the same circle, or in congruent circles, if two chords are congruent, okay, two chords are congruent, if and only if they are equidistant from the center. Okay, so that means that AB is congruent to CD only if EG and EF are congruent. Okay, they have to be the same distance. It goes both ways. So if they're congruent, then we know they're the same distance away. If they're the same distance away, then we know that they are congruent. We're going to see that a lot in the homework as well, I'm sure of it. Right here. Okay, so right here I see that I have FL is 3. Well, that means that that one's 4. It's giving me OP is 4. GO is 5. Okay. Now this one's going to be 3. Remember how we talked about a chord is perpendicular, then it bisects it, like that? That means that these both are going to be 3. Now I can use the Pythagorean theorem. I can say here's 3. Well, this one's got to be something, and this one's got to be 5. Again, it's a triple. 3, 4, 5 triangle. So now that I can say that OP is 4 and OL is also 4, since they're the same distance away perpendicularly from the center, HJ here also has to be 6. That was a lot of information in that one problem, okay? You had to notice they were perpendicular, therefore it bisected. Therefore, these are both the same value, 6. You had to know Pythagorean triple, 3, 4, 5 triangle. And then you had to notice they were the same distance away from the center, and therefore were the same distance. Okay, which is closer to the center of a circle, a longer or a shorter chord? There's a little picture there to help you visualize it. Please put in your answer. It shouldn't take very long at all. Okay, so now, for example, 9.12, this work gets kind of fun. Draw a pair of circles with 4 common tangents, and draw the tangents. So you're going to want to draw the external tangents, and you're going to want to draw the internal tangents, and you're done. Next it says, draw a pair of circles with only one common tangent. Now this only happens when we have an internal tangent situation. There it is. You draw 2 circles, one inside of the other, touching on one point only, and then that point becomes the common tangent, and there's only one of them. Okay, over here, let's see. Draw a pair of circles with only 3 common tangents. Okay, well, if we draw them where they're touching just once in the middle right here, then we're going to have 2 externals and only 1 internal. So that's how we draw 3 common tangents. Okay, Pac-Man. This is a little bit of pie charts. The percent of the pie chart that looks like Pac-Man, and the percent that does not look like Pac-Man. Pie charts come in lots of different versions and varieties, but they show an amount of something that's either hard and easy, or that looks like Pac-Man doesn't look like Pac-Man, or that is there and isn't. Pie charts show visually an amount. So this progression, and we can see that that's more than halfway because it's bigger than half of a circle. And we can see this red light, that's a very small amount because the angle is so small. Okay? So kind of think about, what do pie charts have to do with central angles? I'll put this picture up here. What do pie charts have to do with a central angle? Think about it for a bit. Put down your own answer. All right, so some homework help. If we're looking at this one here, JM is 80 degrees. Well, that means that KL is also going to be 80 degrees. Oh, sorry. Wrong button. KL over here is also going to be 80 degrees because these chords are congruent. Therefore, the arcs they subtend are congruent. That means that this piece over here has to be 100 degrees. And this one over here has to be 100 degrees because they all together have to add up to 360. So 1 plus 1 is 2, that's 200. Plus 160 is going to give me 360. So you should have 80, 80, 100, and 100. If you find out in the homework, there's your answer. Now, over here we have GMJ. GMJ. Oh, that's an arc. GMJ over here. All of this out here is 200. Well, how big is GK? Now, again, remember how it's a diameter and it's perpendicular. That means that this is equal to this, and this arc is equal to this arc. Well, if this whole thing's 200, that means that I have, 360 minus 200. I have 160 degrees left for all the way GKJ. That arc, all of that is 160. But since I know that these two pieces are equal to themselves, I can divide that by 2 and say that GK is 80 degrees. And that goes right there. We can come here, we can say NP. Ooh, that's a good question. NP right here, this segment is 18 root 3. And I want to know what RQ is. So you might be tempted to just say, well, they're the same. But you have to be able to show me that they're the same. And to show me they're the same, we got to show that they are the same distance away from the center, which means I need to know that this is 9. I don't know it now, but I got to show it. And I'm going to show it by doing, if the whole thing is 18 root 3, then just this part here is going to be 9 root 3. And I'm going to do 9 root 3 plus b squared is going to be equal to 18 squared. Oh, that's going to be ugly. I don't like 18 squared. It's too big. But anyways, 9 squared is going to be 81 times 3 plus b squared is going to be equal to 18 squared. Let me just grab my little calculator here on my computer. 18 times 18 equals 324. Okay. All right. So I think I still broke my situation here. So homework help is now over. Anyways, you would solve, that was 324. This was, multiply that out, and you'd subtract it over. You'd square root both sides. You'd find out this is 9. And once you find out this one right here is 9, then you can say, since they're the same distance away from the center, I know that chord NP and chord RQ are congruent. Therefore, RQ is 18 root 3 long. Anyways, I can't do any more homework help because the thing broke. But I hope that this was helpful for 9.2. Fill in your notes, do your homework, and we'll see you in class.